Welcome to the Algebra 3 Fall Semester Exam Review Part 2. This is pages 3 and 4 of the packet. Okay, we're going to start with problem 31, and this is function notation, and this is pretty much a lot of calculator work. We're going to start off with looking at, given the function f of x is 2x plus 1 and g of x is this, find the following. We're first going to find f of a negative 1. So we're going to go to the calculator and we're going to go to y equals, and we're going to put in y1, we're going to put into y1 2x plus 1. And then we're going to do second table, or second graph, which is table, second graph. And it's going to give us a table with x and y1. And I have moved up into the table to where I can see negative 1, and I can see that my key here has got an error in it. Plug in an f of a negative 1. Did I put the equation in right? 2x plus 1? Yes, I did. So this should be a negative 1 is the answer. And basically how this works is this is f of a negative 1 equals 1. So f of 2 is going to equal 4. Okay. Right. Then for a problem like number 32, we look up f of 2, that is, I must have plugged this into the calculator wrong when I first made this key, or I've done it wrong now. No, I wrote this down wrong. This is a 5. So f of 2 is 5. This is supposed to be 5 in the table. It's 5, and then f of a negative 3 is a negative 1, and or negative 5, and you plug that in and you get 1. Now, for a problem like 32, we don't have numbers. We have just adding the functions together. So f of x plus g of x, f of x plus g of x. Okay? Well, f of x is 2x plus 1, and we have plus the g of x. You often want to put this in parentheses, but it's not required. If this was a negative, you would want, if this was a negative, you would want to put this in parentheses because you would be subtracting everything from this parentheses. But it's positive, we're adding everything, so we can just make it a positive and not use parentheses. And this g of x is 3x squared plus 8x minus 2. And this is just a simple problem, combined all like terms. We only have one squared term, so we have 3x squared. We've got an 8x and a 2x that combine to be 10x, and a 1 minus 2, which is a negative 1. We do the same thing for 34, but we switched it up, so let me clean the slate. So we're going to have 34 is g of x minus f of x. Okay. Well, g of x is still the 3x squared plus 8x minus 2, and then we're going to subtract all of f of x, which is 2x plus 1. Okay. Well, if we do that, this becomes plus, that's a minus, and that's a minus. Okay. So we still have just the one squared term, and we have a squared term in the answer, and we've got an 8x minus a 2x, which is a positive 6x, minus 2 minus 1 is a negative 3. Okay. 35 is something called composition of functions. And this is where we have f of g of x. We work from the inside first. Okay, so we do g of x. And here it's all of x, so this first part is just g of x is simply just g of x. The 3x squared plus 8x minus 2. Minus 2. Okay, and that then comes put in here, so now we have f of all of this. So equals, the f of x was 2x. Well, we're going to not write x, we're going to just leave a big gap here, and then it is, what was it? It was plus 1, plus 1. So, all of this 3x squared plus 8x minus 2 all fits in here. We have to distribute the 2 to all of this and then add a 1 to it. And we will come out with, hopefully, 6x. Well, 2 times 3x squared is 6x. 2 times 8 is 16. Then we have 2 times a negative 2, which is a negative 4, plus 1 is a negative 3. Okay, so that is the only example that I'm showing for composition of functions. You have to remember to do the inside first. Moving on to multiplying. All right, number 36 is simply, it's single distribution. Excuse me. 3x times 2x is 6x squared, and 3x times 5 is 15x. Final answer. For 37, we are multiplying two parentheses together. So you take the first term of the first parentheses, which is 2x, and you multiply it by all of the second parentheses. Then you take what's left of the first parentheses, which is plus 3, and multiply it by all the second parentheses. Now, this is called double distribution. Oh, it's not going to let me do that. So, 2x times 3x is 6x squared. 2x times a negative 4 is 8x. 1 times 3x is just itself, and 1 times a negative 4 is just itself. Then we combine like terms. Only one squared term, only one term without a variable, and we combine these to this. Okay. Number 38 is the identical type of problem, but this is a special case called because this is actually factored difference of squares, but we're just going to multiply it out, normal. We've got the 2x times this 2x minus 3, then the plus 3 times the 2x minus 3. 2x times 2x is 4x squared. 2x times the negative 3 is a negative 6. Positive 3 times a positive 2x is a positive 6x. 3 times a negative 3 is a negative 9. We have middle terms, and because these are the same things except with a plus and minus, this is difference of squares, the middle terms cancel out. And what we have here is 4 is a perfect square. Square root of 4 is 2. X is a perfect square. The square root of x squared is x. minus, because it's a difference of perfect squares, 9 is a perfect square. The square root of 9 is 3. So this is actually, we're going to see this as the DOS, difference of squares formula, later on this page. And what the formula is, and you should write this on your review, is A minus B times A plus B equals A squared minus B squared, the difference of square formula. So here we have the perfect square here minus a perfect square. You take the square root of each part, and it's just the first minus the second quantity, then the first plus the second quantity. Okay. Alright. 39 is a killer that gets a lot of students makes wrong. You look at this and you're squaring it, and you're thinking, oh, we're going to distribute the square. So we get x squared plus 36. And you miss the middle term because this is the quantity squared. So it's quantity x minus 6 squared times a quantity x minus 6 squared. We do double distribution. We have a middle term. Since it's the same sign, the middle terms do not cancel out. They add together to be a negative 12, and you get this. And this double distribution is much preferred over any other multiplication method because of what we see here. There is something called FOIL that you can use for these pairs of things, but that falls apart when you have a parenthesis that has more than two things in it. Where if you do double distribution, it works for any size value. You have the first thing times the second quantity plus the second thing plus 2 times that quantity, and it's just worked out. X times x is x cubed. X times x, 3x is 3x squared. X times a negative 4 is a negative 4x. 2 times x squared is 2x squared. 2 times 3x is 6x. 2 times a negative 4 is a negative 8. Now we combine like terms. We only have one cubed term and one term here, but we have two squared terms and two single x terms. You combine those. So bring the 3x cubed down. 3x squared plus 2x squared is 5x squared. A negative 4x plus 6x is a positive 2x, and you brought the 8 down. So that is our quick review of multiplication. Now we're going to go on to factoring. Okay, the very first thing, any time you want to factor, the very first thing you want to look for is the greatest common factor. And for number 41, the greatest common factor, they're both even. The greatest common factor, well, a factor would be 2 for any even number, and this happens to be the greatest common factor. You factor the 2 out, and you get 5x plus 1. Okay. And it's often good to test it. Multiply it back out to test it. 2 times x is 2x. 2 times 5 is 10. This next one, this is the difference of square formula that I was talking about a couple minutes ago up here. Here it is again. You got an x squared minus 4. Well, x squared is a perfect square, which means the square root of x squared equals x, and the square root of 4 equals 2. Now you ignore the sign when you're doing this. The word has difference. It has to be a negative, so you ignore that negative. You take the number squared and this, and you get a and b, or this is the a term, so you have x plus 2, x minus 2. This is a very important formula to memorize. number 43 is the same things. The square root of 16x squared is 4x. The square root of 81 is 9. So you end up having x plus x, 4x plus 9, 4x minus 9. This is a difference of square. So now we're going to go on to 44, our first one where we're going to actually do some old school factoring on. But we're going to use some this is Mr. Clausing's class. I don't do anything without sharing the calculator tricks. Okay. So first, without the trick, you always do, this is a simple one because the leading coefficient is 1, but you always take the first term times the last term and multiply them together. Okay. Well, that's what that little arc up above means. We're multiplying this together. Now this is a trivial one. 1 times a negative 24 is a negative 24. Okay. Over here. Let's erase that. Can I erase? No. Alright, so okay. So in our calculator, I'm going to put this in. So stop, put pause and put, well, let's discuss what I did first. I'm sorry, I'm getting ahead of myself. In the first term, you have first times the last. That's what that arc means. 1 times a negative 24 is a negative 24. So we're looking for two numbers whose product is a negative 24 and whose sum is a negative 5. Okay? Alright. Well, in your calculator, go ahead and put this in. Put in y1 equals a negative 24 divided by x. That's this number. And in y2, put a negative 5 minus x. Put that into hit pause, put that into the calculator and graph. And the graph you're going to see is this. From y1, you're going to get something that looks like this. This is a rational function. And y2 is linear. And this particular linear is going to cross the two graphs like this. And what you want to do is just find the intersection of one of these points. And if I do that, I'm going to find x equals a 3 and y equals a negative 8. And that's the numbers we're going to need. If I did this one, if I had done this point up here, I'm going to get x equals a negative 8 and y equals 3. Well, it doesn't matter x and y. This is one case where I'm going to need both these numbers, 3 and 8. So I only have to find one of the two intersections. And the way we're going to factor by grouping. So let's go back to problem 44. You bring down the x squared. You bring down the first term. You bring down the second term. So the first term was x squared. The second term, the last term was a negative 24. And what's left is the middle term, negative 5x, where we're going to use this 3 and negative 8. And this middle term is going to split into 3x minus 8x. You could reverse the order. You could put the negative 8x first and then the 3x. Doesn't matter. And then what we are going to do is we are going to factor by grouping. Anytime you have a factor and you have 4 terms, try factoring by grouping. So what that means is we try to find the greatest common factor for the first two. We've got an x squared and a 3x. You can always factor an x out from the first one. And we're left with x plus 3. And then you always bring down this middle sign. In this case, it's a negative. And then look to see what we have here. We got an 8x minus 24. The greatest common factor is 8. And here's a trick. Whatever this parentheses is this parenthesis. They match always. Okay, so test your work. A negative 8 times x is a negative 8x. A negative 8 times a positive 3 is a negative 24. If that works, then you're right. So what is left? Inside the parentheses, you have an x plus 3. Well, that's one of your factors. The other one is an x minus 8. That goes here. We have it fully factored. So you multiply the first term times the last term. This is this number. Okay, and you take that first product number, and it's that number divided by x. Always put it in y1. Then y2, it's going to be this number here, not 5x, this middle number. We're looking for two numbers whose product is a negative 24 and its sum is 5. That happens to be 3 and a negative 8. 3 times a negative 8 is a negative 24. 3 plus a negative 8 is a negative 5. So you plug in this. Now, there is one, this graph will look like this, or sometimes it'll look like this. You have the arcs, and the straight line that I had done in blue, it'll just touch one of these two things. And when it does, here I have two intersections again, and I just have to find one point. The third thing that can happen is where you have a graph that, whoops, let me erase this. You have a graph that looks like this, and we have the first part, and you have something like that goes through the middle. No intersections, no solutions, not factorable. Let's move on to, hopefully this pace will pick up. Okay, so we're going to start off with, here we have no real factor. So we multiply the first times the last. The first times the last, it's 1 times 1, it's 1. We have 1 divided by x. Let's erase that, okay? And then the middle coefficient is also 1. You got x. Well, there's an invisible 1 in front of that. And you have 1 minus x. Same thing we did before. Plug that into the calculator, and let's see what we get. Hit graph. For this one, what I got is, and I see that the graphs really hug this, okay? And the other line goes in between and it never touches. It's got no new factor, no real factors. Okay. 46. This is a harder one. 46 and 47 are what teachers or students would consider harder because the leading coefficient is not 1. But using the technique we've just done with a calculator and factor by grouping, this is no harder than any of the others. It's just bigger numbers. Bigger numbers doesn't mean it's harder with the calculator. Okay, so we start off with first times last. Well, the first term is 15 times a negative 4 is a negative 60, and graph that. And the middle term is a negative 7, so it's a negative 7 minus x. You graph those, you're going to get 5 and a negative 12. Notice that the negative 12, you might have to shrink your window or do a zoom fit because that's going to be outside the standard window, but it's still something that you know how to find. And then we go back to the factor by grouping. You bring the first term down, you bring the last term down, you split the middle one up using these numbers. So 5x minus 12x, and then factor by pairs, factor by grouping. You can always factor out an x for the first one, but here we got 15 and 5. We can factor out 5x, and we're left with 3x plus 1. That's going to be the same, 3x plus 1. You bring the sign down, it's a negative. 12 and 4, you can factor out of 4, and you get a 5x minus 4 and a 3x plus 1 factor. And I'm going to skip 47, but here it is to look at. It's all the work is shown up. Okay. So let's move on to 48, some linear problems. Find the slope of a line containing these 2 points. Okay, we have a slope formula, all this great stuff, but remember, calculator work. We can do stat edit. And that's going to give us an L1 and a L2 table. If you don't see L1 and L2, reset the memory. 2nd plus 7, 1, 2. And put in the points. And I need to see my points here. It was stat edit. I had to replace. So you put in a -2, 5, and you put in a 3, 15. And then you do stat, calc, linreg, which is stat, calc, whoops. Stat calc. So the stat button is to the right of the alpha by 2 buttons. Stat calc number 4 is lin reg. You've used this before, so I'm not going to go over this. And you're going to get this equation. And of this is the slope, this is the y-intercept. Okay. Stat edit, stat calc, linreg. Let's clean up this workspace. Okay. Now determine the slope of these graphs. Alright. I showed you that this is 2 up. Remember slope. Slope is rise over run, or it's the change of y over the change of x. Triangle means change of, delta. Delta y over. So the y over the x. So we got the y, you were going positive. This is a positive 2. And the run is a positive 4. 2 over 4 equals 1/2. Okay. Here we're going down 2, that's a -2, and we're going right 5, so it's a -2/5. Okay. Write an equation of a line that contains these points. Stat calc, stat edit, stat calc, lin reg. We get an equation. You know, I'm big on fractions, but decimal or fraction form is this. Let's clean this up. Okay. The gas of a typical mid-size car is 12.8 gallons. If a reasonable driver averages 32 miles per gallon, answer the following questions about the gallons left in the tank. Okay, so all right, we can analyze this, and people have techniques to read the equations and come up with this. Formulas, that's not me. What I want to do is read the problem and make a table. Okay. If the gas tank on a typical mid-size car is 12.8 gallons. So if we've driven 0 miles, we've used no gas, so we got 12.8 left. Remember, it says write an equation that shows how much is left in the tank. Okay. Well, it's 0 miles. You've done 12.8. You have 12.8 gallons. Now, if a reasonable driver averages 32 miles per gallon, answer the following questions. All right. Well, that means if he is driven 32 miles, he's used 1 gallon, so he has 11.8 miles left in the tank. Okay, you do that, stat calc, lin reg. you put this in your table, and you're going to get, a, which is the slope, which is a negative 0.03125, and if you convert that to a fraction that I like, it's a negative 1 over 32. So let's read the question. So it's just read the question, make a reasonable table. Start with the initial condition and use the slope, the rate of change, to come up with one more position in the table. Okay, let's clean this up a little bit. X is delete. I need to delete that. I think that'll be enough. Okay, so let's read the rest of the question. Alright, so we've written, if a function is developed to model the amount of gas left in the tank, what is the slope? Well, most people would say it was that negative 0.03125. Okay. What mathematical term describes the number 12.8? Well, that's the y-intercept. Okay. What is the domain of the function? Well, this is where you need to graph it. Okay, and we start up here and we come down here. Down here is when we have, let's find this 0 for the function. And we're going to find that when we have 0, that this point is this value. This is the x value, how many miles you've driven, where you're going to have 0 left in the tank. And this is going to be 0 to this. This is the domain, is the x. Okay. Okay. The equation. What is those 0? It was this. So this was the actual 0, 409.60, and how much, and then plug this into y1, and in y2 put in 250 to answer this question and find the intersection. And then if 8.2 gallons is left in the tank, how far is the gas driven? This is where you can just plug that number in there, or you can do second table setup, which is second window, and change independent from auto to ask, and you can plug this in. And that is the end of page 4.